In my previous videos, I've explained how to solve a wide variety of rotational motion problems. Some of the quantities I've discussed are angular velocity, angular acceleration, and angular momentum. But what I haven't really discussed is the vector nature of these quantities. So far we've only been concerned with the magnitudes of these quantities, but these are also all vectors. Let's consider a wheel that rotates in the counterclockwise direction. We know that a counterclockwise rotation means that the angular velocity will be positive. However, we can't just say the angular velocity acts in this direction. All vectors need to act in a linear direction. In the case of a rotating object, the angular velocity will actually act along the axis of rotation. However, we need to figure out if it acts in the upward or downward direction. There's actually an easy way to figure this out, and it's called the right-hand rule. Picture curling your hand around the axis of rotation so that your fingers point in the direction of rotation. The direction that your thumb points will then show you the direction of the angular velocity vector. In the case of this example, we see that our thumb points upward, so this is also the direction of the angular velocity. If the wheel was instead rotating in the clockwise direction, you should now be able to see how the angular velocity vector would point downward. If the axis of rotation is fixed, then the angular acceleration vector will also point along it. For example, if the angular velocity is increasing, then the angular acceleration will point in the same direction. If this wheel was instead slowing down, then the angular acceleration vector would instead point downward along the axis of rotation. And if this wheel was instead moving in the clockwise direction, and its speed was increasing in that direction, then both the angular acceleration and velocity vectors would point downward. I mentioned that angular momentum is also a vector, and if we think back to its formula, this one should be easy to figure out. Angular momentum is equal to the moment of inertia multiplied by the angular velocity. Because angular velocity is a vector quantity and moment of inertia is not, the angular momentum vector will point in the same direction as the angular velocity vector. While you won't need to draw in the vectors while solving every rotational motion problem, it's important to understand the vector nature of these quantities. This can be especially useful while solving more complex problems. If anything in this video was unclear, comment below with any questions. If you found this video helpful, be sure to leave a like and subscribe for more fast physics videos. Thanks for watching.